full of dad's hot air. Well, I was 3 years old, splashing everywhere, and so began my love affair with water. On the riverbank with all my friends. Okay, hopefully you enjoy that Brad Paisley Water intro there. Let's talk about our notes. I'll try to make this as fast as I can so that you'll want to listen to it again. Water is absolutely everywhere on Earth. It is in the lakes, rivers, ponds, and streams. It is under the surface as groundwater. It is in all the oceans, of course. It's in the atmosphere as water vapor. And it's also trapped in glaciers, frozen. It's in our bodies. It's in the bodies of other animals. It's in plants. So really, when you see the word hydrosphere, that means everything, and water is everywhere. Okay, talk a little bit about chemistry here for number 3. Water is a molecule, which means it is two different atoms bonded together, and they cannot be separated. If they are, then it's no longer water. Water always has 2 hydrogen atoms and 1 oxygen atom, and that's why people call it H2O, because it has 2 hydrogen atoms. Also, you could call it dihydrogen oxide, and you can ask Mr. Klein more about that and his warning labels for it. Okay, if you look at number 4, please, I think everybody knows that water can come as a solid, liquid, or gas. In a solid, the water has its least or lowest thermal energy. So the molecules barely move. They're kind of locked in place as a crystal. As a liquid, the water molecules have more thermal energy. They can slide past each other, but they are still touching. A gas has the most thermal energy of all 3 of the states or phases of water. The molecules are flying free and are no longer touching. And the hotter that gas is, or the more thermal energy you have added to it, the higher it will rise in the atmosphere. And we see that with sky lanterns and hot air balloons. 2 key ideas to remember with water is water changing from solid to liquid to gas is always a physical change. Even though it looks a little bit different, it's still the exact same chemical formula. It still has the exact same properties. The other important thing to remember is without the sun, there is no water cycle. The sun and the thermal energy or heat that it gives to the water to change it from a solid to a liquid to gas and back again is what drives the entire water cycle. Okay, I won't go too much in depth with this page. I jokingly call this the shun page because you just have to know all these shun words. Evaporation, transpiration, respiration, condensation, precipitation, infiltration, and a few other ones. One really important thing to remember is, if you look at number 14 right here, 2 things happen as warm, moist air rises. Since there are fewer air molecules higher you go in the atmosphere gets thinner. Because of that, the pressure or the density drops. And then the atmosphere gets colder. When the water molecules get colder, they start to condense. They start to lose energy. When they condense, they clump together around tiny dust particles and they form clouds. This is probably the most important idea for weather, the fact that water molecules will rise and rise and rise and rise high into the atmosphere, but then they will eventually condense once they lose their energy and form clouds. I think by 7th grade all of us pretty much understand what precipitation is, and that it can be in any form like rain, sleet, snow, hail, or freezing rain. But it's important to remember that that all depends on the air temperature. The other thing to remember is there's a lot of water that we can't see, but it is still there. As water falls on the land, it's infiltrated by the soil, and we'll learn about the different permeabilities of different types of soil like gravel and sand and limestone and shale. But as water comes across the surface, it's going to find some place to go. It's either going to go into a lake, river, stream, or pond, or eventually the ocean, or it's going to travel into large underground rocks that are called aquifers, or maybe even caves, or it will pool in places large enough to be a reservoir. Any place that stores water is a reservoir. A lake can be a reservoir, a glacier is a reservoir, an aquifer can be a reservoir if it's underground. The clouds are actually a reservoir. We found out a fun fact the other day that the average cumulus cloud weighs 1.1 million pounds. And that's all because of the water that it stores in it. It's important that we know how important water is to life on Earth. Approximately 75% of Earth's surface is covered by water, so it's a habitat for all life in one way or another. If you look throughout history, humans have built their largest cities and their first cities by rivers and lakes, not only for transportation, but so they could irrigate their crops, so they could wash their clothes, so that they could get their drinking water from it. 70% of human cells are made with water. I always say that we can become wilted just like plants or dehydrated. We need that water to keep our cell volume and to keep all of our activities running in our cells. Water keeps Earth a Goldilocks temperature. We have an atmosphere that helps hold heat that we need, but water is a huge heat sink. The oceans especially really soak in a lot of heat that otherwise would be re-radiated into the atmosphere and make it even warmer here. Water has a really unique property of it takes a long time to heat up, but it also takes a long time to cool down. This is why I always say if you go out in the early spring, like late April or May, and you want to jump in the pond or jump in the pool, the water is still really, really cold because it hasn't had enough direct sunlight over the summer months to warm up. On the other hand, if it's September, and maybe the nights are starting to get colder, the water will still be warmer because it's held its heat from the 3 months of the summer. That's an important property that helps regulate Earth's temperature. Water vapor creates clouds and leads to precipitation. The fact that water vapor can change its state and condense back to a liquid and create clouds, that really drives the water cycle. Without our precipitation, especially with rain and snow, then we wouldn't be able to get the water back to the surface where all the animals and plants need it. And one of the last major reasons that water is so important is major chemical reactions like photosynthesis, digestion is another example, require water. So it really does sustain life in a lot of ways.